So what we are all trying to become is a cloud ops engineer. It doesn't matter which cloud, it's ops. So with DevOps is development operations. We're not programmers. We're not going to write any kind of code, nothing like that, right? So bright. So we're going to be um, monitoring already existing systems. For example, I was going through this right here. I want to just explain to you what systems are about. What is a system and what kind of systems we're going to be monitoring and why we need to monitor those systems. I want you guys to really understand their criticality and importance, right? Okay. So right here, boom, this is an application. It's too wide, right? This is a payment system that you see here, right? Right here. You see this? You have Square, Paywire, an American bank card, right? So they issue you a card. Let's take for example, right here, right? These companies right here, right? They issue you a card. They can issue you a MasterCard, a Discovery card, a Visa card, any of those cards. You guys have credit cards, right? Forget about this on the side. Just focus on this, right? This payment ecosystem. I want you guys to understand how payments work and then why, so that you can understand why we monitor. So they'll acquire you a card, right? You take that card, or let's start down here, right? This is the customer. Where am I? Hold on. Where is the customer? Right here. Issuing, acquiring, right? Okay, yes, start down here, then we'll go up. Right, down here, right? This is the customer account down here. This is the merchant. The merchant is Walmart. The merchant is Best Buy or the restaurant where you buy food from, right? So you are the customer here. You have your card hold. You're the card holder. Your Bank of America issues you a card. This is the issuing bank, issue a card in your customer account. So you have an account, right? Now, when the bank issues an account, the bank issues you a type of card. It could be in the MasterCard network, a Visa network, Discovery, American Express, all those type of cards. So your card can either be Visa, MasterCard, American Express, or what's the other one? There are three major types of card networks in the world. MasterCard, American Express, Visa, and uh Discovery, I believe. Discovery. Capital One is MasterCard. Wells Fargo is Visa. Bank of America is Visa. Uh Navy Federal is Visa. So you have Visa, MasterCard, or American Express. Let's stay with those three. So here there's is Visa. So this bank has issued you a Visa card. The customer takes the card, right? And wants to use it, right? So let's say they want to pay, they want to pay through PayPal. You don't want to pay directly with your card. Let's say you're trying to buy something online and you need some kind of a protection. You know, PayPal helps with protection. Cash App, all these middle services, Zelle, they help with protection, right? So you go to PayPal, you put your card in PayPal, and then you use PayPal to buy, right? So the issuing processor here is PayPal, and it's a Visa network. So PayPal accepts your card, and then now, boom, you go now, you use your card, right? And you pay for the services. So when you pay to PayPal, right? Right here, you have PayPal. So the merchant also has PayPal. That's why the way you go to the restaurant, you ask, do you guys accept PayPal? Do you guys accept Stripe? Do you guys accept Apple Pay? It's all this is the same thing. You put your card in Apple Pay, you put your card in PayPal, you go and you buy through PayPal. Now the merchant has his own bank. The merchant has his own bank. You can be using Visa here with your PayPal. The merchant using MasterCard. The merchant has as their bank account with, I don't know, it could be with Business Bank of America as a business account. They accept all cards. So they have acquired one of these processors that you had. So they have PayPal. So when they receive payments, the payment goes to their own PayPal gateway, and then it goes through, and then is They acquire the payment. It goes to the whole clearing system. That's why it takes 48 hours because you have to clear. It has to go from your bank to their bank. That's a clearing process. It goes through something called a clearing house. If you know what a clearing house is clearing house is like a federal bank, Federal Reserve Bank. There's one in every major states: Texas, Minnesota, New York, California, Atlanta. They have federal banks, so it clears. But the bank doesn't clear each individual transactions. Every 48 hours, they combine all the transactions and they clear it to the clearing house, and then the money comes in. You get when you for your paycheck, you get paid about 3 or 4 days before your actual pay. But it actually enters your account on Friday because that's the date it has cleared, right? So this is how the payment system works, right? So the card comes here. This is a Visa network. The issuing processor is PayPal. You make a payment PayPal or to the Visa PayPal right here. The merchant accepts it because he also asks PayPal right here. And then boom, the payment goes to, and then it goes to their back end system. They use Square to swipe your card, right? Square is a system that you can swipe your card. That machine that's like a Square. So they use that machine as on their merchant. They connect it to PayPal, and then they acquire that amount, and it goes to their bank. So that's the payment system. Behind this system, you have three things. What are the three things that you have behind this application? Behind this whole system, what are the three things that makes it work, makes it happen? What are the three things? This issuing bank here, what application do they have to use to issue that card?
Web server application layer in database.
Yes, thank you. So let's say Wells Fargo Bank. Wells
Thank you.
Fargo Bank, Wells Fargo Bank alone has these three things. 1, 2, 3. Only Wells Fargo Bank alone. Visa has the same thing. Visa is a company, right? Visa is a company. Wells Fargo alone has this. WellsFargo.com. And because it's so many customers have Wells Fargo probably has about 600 servers here. And 300 servers the web layer, right? And then our databases that have about 160 databases. And this the application serves 200 million customers worldwide on the United States. 200 million users. Visa card network doesn't deal with customers directly, right? www.visa.com. They deal with business to business. So that they're B2B, business to business. So Wells Fargo go to them and say, hey, I need 100 debit cards. Then Visa. So when you request a debit card with Wells Fargo sends a request to Visa. Visa produces your card with the card number and sends to Wells Fargo. Then Wells Fargo sends to you. Or it just goes directly from visa.com to your address. So Visa has same thing. Web, app, servers, and database servers. And for this case, Visa has, since they already do business to business, it's not very much. They may have 200 web servers, 200 servers here, 300 application level, And since there's still so much information, it can have about 180 databases. Okay. The merchant, it could be a restaurant. Let's say the restaurant is what did they call that thing? What's the name of that restaurant? Ah, just give me a restaurant, any restaurant, or anything that's familiar with you guys.
Cheesecake Factory.
Yeah, Cheesecake Factory, right? So www.cheesecakefactory.com. So they have the same thing as well. They have a web server, they have an application server, they have a database server. Let's say here they have about 300 web servers. They have 600 servers. And they have 120 servers. Who can tell me why they have lower databases than all these other two guys? Anybody? They have lower databases than everyone else because they don't store customer information, right? It's a restaurant. You come and eat, you go. Come eat, they don't store your name, number, they don't store your information. So they have lower amount of databases. So this is why we monitor systems. These systems need these three things to run effectively. These systems, this one needs Visa. If Visa network is not working, you cannot use the debit card. That's why we need to monitor the web server, the application server, database servers for Visa. They have 900 million customers. If their system goes down, you cannot buy, you cannot use your card online or anywhere. That is the reason why it's so impactful for us to connect, for us to monitor the systems. Okay? Same thing here. Apple Pay and Google Pay. Security, how we secure Apple Pay secures our information, right? What happens when you type URL into the browser? It goes to a DNS resolution process. And then the e-commerce server connects to your bank, and then Apple Pay puts your information in your Apple Pay. Same thing with Google Pay. Okay. Where's the other diagram I wanted to explain? So that's why we monitor systems. Anyway, so here we're trying to build an AWS monitoring project to give you hands-on process, right, on how to monitor an application. So here, you see this is the Prometheus thing that we're going to use to monitor the application, right? So here is your application, right? www.xyz.com. This is the application. And this application serves data. There's load balancer here, similar to here, right? Connected to this load balancer, this in the middle that connects, right? So let me pause sharing for a little bit in 1 second. So this solution is pretty much just saying that we're going to use Prometheus to collect logs. In monitoring, right? And let me go here. I'm sorry I'm all over the place, but I want you guys to understand. In monitoring, right? In monitoring, there's something called log collection. Let me just skip there real quick. in monitor, you need to monitor the server health and utilization. So the two things in monitoring. So instance health and performance, right? There are existing services that I can use to manage that. And then utilization, unused or underutilized resources, and then network performance. That's the key thing about monitoring. So you need to collect logs. You need to collect logs and then analyze those logs. In those logs, you can extract metrics. Metrics is pretty much just a measurement. Like, for example, if you want to measure CPU utilization, you say CPU percentage, right? Monitoring percentage, something like that. Okay. So Amazon CloudWatch is a service to use monitoring. So that when you collect logs, that's when you'll be able to see things like CPU usage, query time, performance, right? So this solution that I gave you guys here is just a project to create these things. In any cloud environment you choose, it doesn't matter. Ensuring that applications and infrastructure components are always available and performing optimally is crucial. Traditional monitoring approaches can be inadequate, especially when dealing with dynamic and distributed systems on platforms like AWS, Azure, or GCP. I embarked on this project to build a reliable monitoring system that could provide continuous insights into my applications and infrastructure, coupled with an automated delivery pipeline to streamline updates and reduce risk of human error. So the tools that will be used in monitoring are Prometheus. Prometheus is an open source monitoring solution that excels at collecting metrics from various endpoints. Endpoints are simply servers. A server is the same as an endpoint. Take note of this name. Endpoint is the same as a server. From various endpoints and providing powerful querying capabilities. Querying means requesting, reading. Query means requests. Querying is the same as requesting, the same thing. So powerful request capabilities. Alert Manager works alongside Prometheus to handle alerts. Whenever you collect logs, you need to also do alerting. So people are aware of, oh, okay, there's an issue with, there's a high CPU. Because you cannot watch, like you just saw here, right? You cannot watch 600 servers at the same time. You can't watch it, it's impossible. But you have enabled monitoring on all of these servers, and you just sit down on your dashboard you're watching. If there's something with any one of these servers, you will get an alert. You get an alert, email alert, text alert, or a phone call will come through. So we're going to see something called pager duty very, very soon. We're going to learn pager duty, right? It's real-time incident response and on-call tool, right? We'll create a free trial. You get like a phone call or text message about something has happened. Then we'll also learn AI ops as well, which is a way for us to be able to automatically resolve some solutions that doesn't need human intervention. So we'll learn some AI. That means that there's some issues, for example, restarting a server that a human being doesn't have to do. If a specific error occurs, we can tell AI to go in there and restart the server. That's all. That's the power of AI ops. So I will teach you guys AI ops as well, because it's something that's very new and high demand as well. It's good for you guys to know. So you need to be alerted. Black box exporter allows probing of endpoints over various protocols. Allows probing of servers. Probing means querying the servers. So the black box exporter, Prometheus collects the logs. Black box exporter goes now and probe the servers over HTTP protocols, over SMTP, over HTTPS, enabling us to monitor the availability and performance of services from an external perspective. That's a black box exporter. Then a node exporter works with Prometheus that collects the hardware and operating system metrics from the machine. So this is a Prometheus node exporter right here, right? It collects metrics, pushes metrics to Prometheus, right? Prometheus now, black exporter uses Prometheus to check, right? And then the alert manager notifies you via Gmail. Alert Manager collects the metrics on Prometheus, notifies you via Gmail. If you work for Geico.com, it notifies you via Kwasi@geico.com. It notifies you. So that's what this system is about. We're going to install Prometheus Node Exporter on a VM. This guy is the one who collects the logs from Geico.com servers, Geico.com database, right? Collects all the logs from them. It comes here, it fetches the logs, sends it back to this guy, and it comes here and collects all the logs. All the metrics are here. It now sends the metrics to Prometheus, right? And Prometheus uses Exporter to check what are the metrics in there. And then Alert Manager say, oh, we have high CPU when you say high CPU. Prometheus analyzes the logs. So there's high CPU. Alert Manager now go here and say, oh, okay, I'm going to notify the customer and notifies you. That's what this system is about. It's a very simple solution. And then we'll just use AWS for its scalability and reliability infrastructure, right? We'll just use AWS as our host monitoring tool. And so for us to do this application, we're going to create a Java application, right? This box here, this box that you see here, it's a Java application. This is the square box, this one, right? That we're going to use to mimic a real application. Then we're going to install the other things that to monitor the application. So the infrastructure setup consists of two main components: monitoring instance, dedicated EC2 instance on AWS running Prometheus, Alert Manager, and Black Box. This is where you have to install Prometheus, one instance on its own. Then the other EC2 instance is to run the Java application with the node exporter. So we put the node exporter on the Java application server. That's why I'm saying to you that every server that you see here will have a monitoring agent installed on it, so that you don't have to monitor all the servers all the time. If you install the monitoring agent on all of these servers, you just sit back and chill. The monitoring agent will send the metrics to Prometheus. And then Black Box Portal will check it and then analyze it and say, oh, and then the Alert Manager will alert you. That's why we had to install Prometheus twice. We have to install the node exporter on the application server, and we also have to install Prometheus on the monitoring server. And then we're connecting the node exporter to Prometheus. So these two servers need to talk to each other. That's it. So this is as we're connected. So you see here, they create the instances, launch instance 1, launch instance 2. This is called Terraform, right? It's an automated method to create the instances. We can do Terraform as a bonus. It's more of a DevOps thing. It's not more for SRE. It's more of a DevOps thing. We can do at the end if we have time, right? You choose the AMI, there's Ubuntu, AMI, instance type, security groups, and then that's for Terraform, right? The manual method is down here. And I want you guys to do the manual way, right? You can download Mobile XTEM if you want, if you're a Windows user. And then here you download Prometheus, install Prometheus, download the manager, install the manager. You can replace this with the latest version for Prometheus. So it means you copy this URL. You copy this URL. You go here. So let's go back one. Let's just go. And then you look for Alert Manager right here. Or you just type it on Google. Alert Manager download. Where is it? Back to Prometheus right here. The most recent version is let's see. Let's search for this. Let's see if it comes up. Okay, it's downloading. So if we go back to releases, there we go. So, and then alert manager, where is it? Where is it? Where is it? Where is it? Install download section right here. And then version 3.00. So all we got to do is come here and replace this with version 3.00, replace it here and download it. You see that? So we'll just replace this with version 3.00 and download it, right? Same thing here, we'll do the same thing for Alert Manager, right? If you're doing 3.00 for Prometheus, you come here, look for Alert Manager, and you do maybe 0.28, right? And then you see that all here. But the most recent release, you're doing the Darwin or Linux one, right? So you just copy this link. You come here now. Where is it? Come here and replace this right here, right? Or you can still do this one, but this one is very, very old, right? You extract the file. It's Linux command for unzip. You extract the files. You extract that file. You extract this file. You extract this file. There are only three things: Prometheus, I imagine a black box exporter. On the monitoring instance, the first monitoring instance, this instance here, this instance, VM1, this one, monitoring instance. That's where you download and extract those things, right? So once you're done, you extract them, you copy the binaries of what you have extracted, each of them to user local bin. So you do a sudo move to user local bin, not the zip file, but what you extracted them, what was extracted to move local bin. Move it for Prometheus, move it for Alert Manager, move it to this. The reason why I move it to this is because everything in Linux that executes, that runs like an application, because this is an application, right? So we're going to come up, it's going to show us it's going to come out as an application. It has to be in the bin directory. Bin is a folder that executes software, that runs executable software. So that's why I'm moving it there. That's why I'm moving it there. After I move it there, you clean up your local home directory. Verify your installation by running this command, and it should work. When this works, you're good, right? Then you run a sudo app update. Then now you begin the Java piece, right? Setting up the application instance now. That's done. So did you guys get to this part here? Were you able to see this? Kwasi?
Yes.
Okay, good. So now setting up application and node exporter on the application instance. You do all these steps. You clone you do a git clone on that Linux box, right? You clone it. You download this. Replace version 1 with the latest version. Same thing. You go online and you make sure you look at the most recent version for this. Node exporter. Graphite. Node exporter. That's it. Boom. This is the most recent version right here. You copy that. 1.82. You come back here. You replace that. 1.82. It's 1.1, 1.6.1. Replace that. You extract a tarball. Copy the user local bin directory. Boom. Clean up your files. Make sure node 4 is running. Start it up. To start it up, you run a no hop node exporter 4 on this ampersand. Boom, it's running. You copy your public IP address. You put HTTP, your IP address for your VM, for the application VM, color port 9100/metrics in your web browser, and boom, it will come up. You see this page. Now you start building your application now. Run a sudo apt get install Java. To build a Java application, you need Java software. So you install Java software on application -y. You install Maven. Maven is what is going to be used to build the application. Java is just a software. Maven is used to compile the application. You install Maven -y. Now you go into that directory. This directory right here that you downloaded to your machine. Where is it? Git clone right here. Download this application, board game. It's a board game. This is the application. It's a simple chess board game that you clone to your local machine. Right? If you go to this right here, .git, it's a full application. It's a full application. How to run it. Clone the repository, open a project, run the application. Done. Username, that's it. Username is Bugs. Password is Bunny. Username is Daffy. Password is Doc. That's it. Right? This is a Java application. All these things are all Java applications. Jenkins file, everything. All these files compile to make up the application. You extract that. You have this notepad. You build application. You install Java. These are called dependencies for the Java application. Java is a dependency. Maven is a dependency. You sit in the location. You run a Maven package. When you sit into this board game, all these files that you see here will be in that location. All these files will be there. This is the most important file. This pom.xml is what the Java application really needs. Pom.xml. Without this, it will not run. This is it. All these things like this, pom.xml is calling other files, database name, application name, web server name, everything. This pom.xml file is the most important file for Java application. It's going to be calling other things. Everything is in here. This file refers to other files that are here. Okay? The deployments of the YAML, that's it right here. Board game, everything, the image, Docker image, everything, right? So once you do that, you do run a Maven package, you build the application. That's why you say build. That's why you say you're a build and release engineer, because you build the application and now you run the application. You now set it into target directory, which is under this directory, targets. And then you run a java.jar database service, this, and you replace your Java file name with the actual name that you have, not this name. This will not be your file name. Your file name will be something different based on what Maven package named the file. You run that, and then you open up the same IP address and port 91 and on the browser, and you will now see this application right here. You put your VM IP address and port 8080, sorry, not port 9100. Your IP address and port 8080, you see this application. You can log in. When you log in, the username and password is here. Username is Box, password is Bunny. For users, for manager, the username is Daffy, password is Doc. You log into the application. Now you log in, the application is running, and then monitor instance is running. So you have two things running now. Boom, you're good. Now I want to create the alert rules for file Prometheus so that when something happens, we can be alerted. You now go into the path where Prometheus is installed, which is where user local bin. User local bin, that's where it's installed. You go and create this file, Nano. Nano is a tool that we use to create files. If you're struggling with Nano, use VR. This is how Nano looks like. Sorry, guys, let me show you. I love you guys so much, right? I have to really show you how to cut. I can't just give you the solution. I want you guys to try, at least, right? This is my terminal on my local laptop, so don't be surprised. There's nothing strange. It's just a simple terminal. This is what Nano looks like if I do let me see it into documents. Nano tests dot YAML. It's like this. Insert. You just type what you want. Type your stuff that you want, or you copy and paste. When you want to save it, what do? You have to first of all write the file, right? So you see here. Were you guys able to work with Nano?
Yes, we did this step.
Okay. So I don't need to say, okay, good, good, good then. How do you save a file in Nano?
We were given another option. We give Control X, and before that, before to log out, we ask you if you want to save or not. And you say yes, you want to save, and you press enter, and you get out. You're going back to the normal terminal.
Okay. It's different for this guy. It's where is it? Command X, escape, and then X. I want to show you guys VR. That is actually easier. Uh, the Nano is a very, very old tool. Escape, X. Let me just close this out. I want to show you guys VR. Let me show you VR real quick. VR is easier. You don't have to use Nano, right? Uh, what's supposed to be basic? So, city into documents. VR, let's just say test.yaml. This VR, you type I to insert, and you type your stuff. And when you want to save it, you hit escape on your keyboard, W, Q, exclamation mark, that's it. If you run ls-ltr test.yml, that's your file. You can cut into it, test.yml, and that's the content of the file. So you don't have to use Nano, okay? You can use VI. But make sure that when you're using VI, you're doing sudo VI and then the file name. In this case, sudo VI alert rules, right? Like that. And then you ask for my password is, because I'm on my local machine. Then I'll come now and I'll copy everything in here. Everything in here. And paste it in here. But careful though, look at what it says. It's asking for some information that you need to edit, right? So when the instance is unavailable, right? When the instance is unavailable, you get this message, service unavailable. That's how you get in your email. They will show you the instance ID, right? Service unavailable, high memory usage, file system is full. That means the disk is full. These are the alerts that we're creating. Host high CPU load, right? A host out of disk space, right? You have host out of memory, website is down, right? So the rules that we're creating. This is very, very good project because on the job, you have to create this same monitoring. You have to create monitoring on new services that are going to be created. You save it and you exit from there. You save it, escape, column, WQ, exclamation mark. You do ls-ltr for alert rules. That's your file. So you don't have to be a DevOps engineer, but you need to know how to create monitoring as an SRE. It's your job, right? You're a monitoring guy, right? So you have to create monitoring. Okay. So now you've done it for alert rules. Now you're doing it for Prometheus and YML. And all you have to do is nano, and you add this file name in that file. sorry, VI. You can do VI. You come in here, you do VI. What's the file name? Prometheus.yml. This is on your application server, guys. On the application, not the monitoring instance, right? All right. That's it. So the Prometheus file, the Prometheus now knows where the alert files is. So it knows where to send the alert. Are you understanding how we're connecting these things together? Update the Prometheus configuration. Add the alert rules to Prometheus so that Prometheus knows where to send alerts so that the alert can send it to you. And that's it. Alert manager configuration. That's it. Rules files. This. That's it. Save and exit.
Sorry, Libo.
Go ahead.
So I think where we stopped was us not being able to identify where the Prometheus file was. I know it's meant to be on the
What was that?
application
What step
server.
was that? 4.2 or where?
Yes, this edit, 4.2. We didn't see the file.
Oh, no. The files in user bin directory.
So we went to user bin. It was just executable files that was listed there for all these other monitoring tools.
It was empty.
What file was empty?
Prometheus file.
Of course, it will be empty. Of course, it will be empty. Add the alert rules file to the Prometheus configuration. And no Prometheus file. Of course, it will be empty. That's all that's in the file. That's it. That's all that's in the file. This file, this Prometheus.yaml file, has its content in the rules file, which is this other file. Which is this file. Guys, look at the diagram now, the beginning. This is Prometheus. This is our VM, application instance. We collect metric and send to Prometheus. Prometheus sends it to the alert file, alert manager, and the alert manager sends it to you. Of course, it will be empty. It has to be empty now. This is the only line in the file. Don't you see it here? Rules file, that's it. That's the image. Everything here is still empty. Look at that, alerting, empty. Unless alerting is alerting, under alerting, alert manager, static config, targets, it's empty. There's nothing in here. Then the load rules once and periodical, that's empty. Only thing here is a red. Everything is blue, means it's empty. There's no, it's a key pair file. There's no values in here. Everything is empty. Right? Everything is empty, guys. That's how it's supposed to be. It's all about following instructions. If they tell you to edit the file and you cannot see a file, create the file. Right here, edit Prometheus file. Create the file. Right here. Did they tell you to, oh, they tell you to create a file here. So you created a file. Yeah, they did not tell you to create a file, so you didn't see a file.
Yes, to be honest, that was what confused us. That edit instruction. So we thought there was already a file existing when they said edit.
Exactly. I get it. I get it. I get it. That's why I'm here to guide you, right? So they say when you install Prometheus here, Prometheus normally comes with default files. Okay. Normally comes with default files. So maybe the most recent version that you installed didn't come with the default file. So you have to create it. If it doesn't exist, you have to create it, right? Create an iRules.yaml file. You come down here, the file does not exist, you create a file, right? You update the configuration, and it looks like this. You save and you exit. You restart Prometheus. Or if you want to run it manually, you go to the Prometheus directory and you run this /Prometheus run. Now Prometheus will start using the new alert rules defined in the Prometheus files. So the alert rules are not defined in the Prometheus file itself. It's defined in the alert rules file, and then Prometheus uses that file. You can verify by navigating to your monitoring instance. All of this is done in your monitoring instance, sorry, not your application instance. Go on your monitor instance 1990/rules and you check. Why add the alert rules file? Adding the alert rules file is crucial for effective monitoring and incident management. Here's why. Proactive issue detection, customized alerts. We don't want to put the alerts directly in the Prometheus file, because if something happens or want to make a change, we need to come and change the Prometheus file directly. We're putting the alert rules file. If something happens, all we have to go and do is edit this file. Prometheus is still running. It's like this. When you want to change the oil of your car, you need to stop the car gets cold before you change the engine oil. No, we don't want that. We want to be able to change the engine of the oil engine of the car while the car is running. So what does that mean? We'll have a different engine in the same place where the engine that is running. So when we want to switch it, all we do is what? We just unplug our starter from the current engine running to the engine that is not running. It will take us 2 seconds. That's what's happening here. If we go make modifications here in this file, the name of this file is already in Prometheus.yaml. So Prometheus know of this file. So all we have to do is make changes in one place. We'll make the changes in one place here. And we'll make changes here. We'll just come and restart Prometheus. It will pick up the new changes. That's it. Right? That's proactive. Improve response time, integration visibility. That's it. In the essence, when this file ensures your monitoring setup is not only watching, but also actively managing system health, right? Now, connect the black box exporter and monitor to Prometheus. Now we're going to connect all of these 3 things that I've installed up here in the monitoring instance. Now I'll connect the monitoring instance to the application. So we're going to do that connection right here, right? In this Prometheus.yaml file, again, the Prometheus.yaml file you already had, they were created up here. This file that you created here was in VI Prometheus file. You're going to come now and put this in that file with your monitoring IP address. You're going to change that, this column right here. You're going to put all of this. Your targets is your application, the Prometheus instance, sorry, right? The thing in green tells you what to put. Your VM instance, this is your application instance, IP address on this, right? And then these targets here. And then your VM instance again, you change that. And then your source labels, you leave all these things as it is right here. And then you replace this. And that's it. When you do that, you restart Prometheus. Prometheus will now pick up your application instance and you pick up the black box exporter running your application instance and pick up the monitoring instance as well. And that's it. You configure, if you want to configure email notifications to receive alerts via email, you need to configure Alert Manager to send notifications when certain conditions are met. This involves editing the Alert Manager file, set up routing and email configuration. So Alert Manager email, you go in there, you set it to this file. You do via Alert Manager.yaml. We already have this file by now, so we know where the file is. We're going to come and add email notification in here. This is the configuration file for email routes by, right? Wait 30 seconds, email notifications, name of the receiver. This is your email. You put your Gmail here, gmail.com. You put a test, send that email. Then you put SMTP Gmail. That's the port number for Gmail. You put your authorized username, authorized user email, your email address, your password to your email address must be in there. The password from Google, right? And then that's it. Generate your authorized. Yeah, you need not your password that you use to log into your Gmail account, but you can generate an auth password by Google. This is how you do it from Google. Google app passwords. I've done it before. It's a specific process to do that, right? You do that step, it'll give you a password that you use for the application. So Google will give you a password that the system can use, not your personal password that you use, but an application password. That's why it's called application password, app password. So we give you that password. And you now configure the rules, right? Source match. The rules are which one is severe. You have critical, you have warning. Critical means you need to step in and do some troubleshooting and work. Warning is just a warning. Warning can be avoided, can be ignored. But critical means you need to get a step in, right? This rule ensures that if a critical alert is active, warning for the same alert dev will be suppressed. So if something is critical, then it goes from warning to critical. So when it leaves from warning to critical, the warning alerts are suppressed. So you're not gonna get many alerts, right? And that's it. You restart the Alemanda tool to complete the project. Now, when you go on this Prometheus, now you now see instances, website down. You now see how many is active, and that's it. Let's assume the website is down. Let's act as if, let's go make as if we'll shut down the application instance. We'll now come back and we'll now see this red that here is down. And you get an email notification like that. Website is down. And that's it. That's it. It's a great project, guys. Only this project alone can get you a job. Only this project alone can get you a job, guys. So are we now clear? Can we get it done this weekend?
Yes, I think we can try it.
Okay.
Excuse me, Jibo. Since we're going to, is it possible to continue from where we ended, or we have to?
If you guys are ready, if someone is running their EC2 instance, why not? What's my own? If someone is running their EC2 instance, why not? Yes, now. You can continue from where? Who was running with their EC2 instance?
That's what I used.
I still have mine running actually.
It's a team project, guys. Why are you people working as individuals now?
We're doing it together. Just that one person was sharing his screen, and we're also practicing on our own instance at the same time.
It's a team project, guys. It's a team project. It's a team project. It's a team project, guys. It's a team project. Please, please, please work as a team. Okay. So that's it. Any questions on the project? It's a team project, guys. That means that everyone contribute. One person will create two EC2 instances, and you guys will watch how you guys do it, watch the steps. You guys don't be doing it on your own. It's a team project. After you're done, you can record it as well. I have Zoom. You can record it as well. Afterward, you're done with the team project. You guys are going to take screenshots, put it on the Microsoft Word document, and submit it together. When you submit it, you all put the names of people who are part of the assignment. So you put group, you put presenter, quasi, attendees, you put their names, and then you send me the email. It's due before Monday at 7 p.m. All projects are due before Monday at 7 p.m. So right now, you guys are behind. Because I'm going to give another project this weekend. So you have this project and the one I'm going to give this weekend. Every Saturday or whatever you guys choose, I'm hearing that Saturday doesn't work for you guys. There'll be a project. These projects is what you will use to speak in your interview to get the job. Let me say that one more time. These projects are what you will say you did in an interview to get the job. In the interview, you will say that I work in a team of 5 or a team of 9 people. You will call the names. You say, I work with Kwasi, I work with Kobe, I work with Elvis, I work with Isabel and Roslyn. These are my team members that we worked on together on this project. We did a share screen. I will configure Prometheus to create alert and monitoring. They're like, oh, okay. What platform did you use? Oh, I work in AWS. Oh, okay, cool. What application were you monitoring? Oh, I'm monitoring Java application. Okay, nice. Okay, cool. So you know how to create monitoring for on Linux boxes? Yes. And that's great. What operating system did you use? Oh, I use Ubuntu. You keep answering questions positively, that's how you get the job. So it's important that you work in a team. They want to know that you're a team player. It's during when you're preparing for interviews that you really work alone. Now you need to work with people. There are things that you think that you know that you don't know. You may think you know, but Kwasi knows something different that you don't know, and you know something that Kwasi doesn't know. So now you need to work to each other and share. Last day of class is December 11th. Last day of class is December 11th. That's barely 5 weeks from now. So you need to work with each other right now to exchange knowledge. Some of you have understood better than other people. Share, ask, learn, share. Okay? Because the way that you understand something, somebody might understand it differently. So I'm advising you work with it together on this project. Again, use VI. Don't use Nano. Use the VI editor. Guess what the VI editor is? Guess what the VI editor is in the Linux command cheat sheet. All those commands I just used, they are here. It's here in this cheat sheet. All the commands are here. Okay? Any questions? Okay, cool. Let's go back to Cloud SRE. Want to take a break? Let's take a 5-minute break. Yes? How about take a break? Yes, I need a break. I'm not feeling well. Yes, sure. Okay, so we're gonna continue where we left off with SRE. I'm gonna hide this floating stuff. Hide floating files. So last class we talked about what's an application, a front-end layer, application layer, back-end jobs. I will talk about all these things, right? Remember? Settings are going to be monitoring, types of applications, right? If you don't remember, watch the recordings, please. So now I want to talk about user types. The type of users that use our applications. It's important for us to know the types of user applications because those are the people who will complain that something is wrong. So it's important for us to know what kind of types of users are there. So who are these users? You have application users, right? They're the consumers, the customers. They directly interact with the application. For example, the banking portal, wellsfargo.com, the one signs the checking account, the app on the phone. So direct application users, right? Consumers internal to organization are the direct employees. So you have the directly interact with the application. These are the customers, application users. Okay. Then you also have consumers internal to the organization, direct employees. For example, the help desk ticketing portal. For example, servicenow.com. Those are the internal application users. So you have direct application users, you have direct consumers internal to the organization. You have federated users, application used by third-party vendors. For example, ADP. ADP is used for your paycheck, right? ADP is used to provide your paycheck. You have Workday. It's used as an HR system. You have JobVite. JobVite is also an HR system that companies use, right? Let me show you this guys' tool so you don't think I'm speaking. Uh-oh. ADP. Huh? We're still running. ADP is a payroll system. You have Workday. It's also an HR system, platform for HR finance planning, right? So these are all federated users. So when they connect this tool to your company, they are federated users. The word federated stands for integrated or connection, right? So these are applications used by third-party vendors. For example, your timesheet is, done on ADP. So these are these users. And then you have application integrations, right? Interfacing applications. For example, the scheduler jobs, right? The US Post Office API, the Visa Network API, right? Stripe API. These are interfacing applications that integrate with the applications, right? For example, Priceline.com or Expedia.com integrates with Delta.com to collect flights from Delta and push it and show it in its platform, right? What am I talking about? Priceline.com, for example, integrates with other airlines.com, right? Like Delta.com, AmericanAirlines.com, integrates with them on the back end of this application so you can show their flights on his portal. Look at that. It just showed you right here what they have, right? Delta, United, American Airlines, British Airways. So they have an API integration with each of those airlines so that those flights can show it here. That's what is called an application integration user. Okay. So you have 5 types of users: 1, 2, 3, 4, then 5 IoT devices, like a scanner app. These are the apps that, for example, at Walmart, you have the cameras that, the scanning machine, self-checkout. The self-checkout that scans the food. The scanner app is the IoT device. So that's also a user as well. Because that application that runs it, the application that you use to scan your groceries at the barcode at Walmart, that application has a user as well. So if that application user for IoT devices is saying, hey, I have an issue, we need to check that very urgently, because without that, users cannot scan their grocery or their pay in Walmart. And if you cannot scan your grocery at that particular kiosk at Walmart, what happens? You call for a service attendant to come and shut down that self-checkout place to shut it down until they can go resolve what the issue is, right? So the scanners, most scanner apps, those guns, that beep, 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 those are all IoT devices. They have their own user. They have their username and everything, okay? So this is a human user, human being. This is human beings as well. This first two is human beings, right? This first two is human beings. And this one right here and this one are all system users. That means computers, not human beings. So the only two users here are human beings. This one is the customer that is paying us money. And this one is the customer that works internally within the company. So where do we fall? Where do SREs fall? Where do we fall among these 5 users?
Internal customers.
Where? What did this? Where? Show me which one.
Consumer internal to organization.
Okay, I was going to say, where did you see internal customers? AY is the most popular guy in this class, guy. Everyone clap for AY. AY always sees something that we don't see. AY has 4 eyes. So, characteristics of this direct users. So we're going to break down each user, right? Each of these users, right? So the first one, direct consumer. Direct customer interface. They have the fastest graphical user response, right? We try to make things as fast as possible for them. These are our people that pay us money. The customers of Bank of America, the customers of Geico.com, they're the fastest. So we have to make sure they see things fast. When they click on something, it should be very, very fast, right? Such applications are very critical due to business impact. For example, Netflix.com, HBO Max, Facebook. When you click on there, your movie has to be play fast. If you click a movie and the movie is slow to play, you can cancel your membership. When you cancel membership, Netflix loses money. So Netflix wants to make sure that when you click play, it plays very, very fast. So we put a lot of memory and CPU and latency is supposed to be fast. Everything to be very, very fast. What does that mean to us? Because what does that mean to us, the SREs? To us, the SREs, the customer login should be successful. We should have about a 95% or 99% success and 1% failure rate. This is what we use to define what is called a service level agreement or service level objectives. Every customer should be able to log in successfully and only 1% failure rate. That's our goal. We're going to set that objective, the service level objective. We're going to get there. So that's one of the goals. User experience monitoring. We're going to monitor API response time. That means when customer sends a request to our servers, the server should respond fast. So we're going to monitoring the API response. Also, when a server sends a request to our servers, the HTTP status code should be success. And success code is always what? Code 200. So we want to also always see code 200 when we monitor our dashboard. We want to see only code 200. We want to see everything green. If the response is less than, is 10 milliseconds, 10 milliseconds. What? 10 milliseconds, it means it's fast, right? Latency is fast. Anything above that, we need to investigate what's happening. So we want this thing to be green, we want this to be green in our data. This is a metric. This is a metric that will come and add in our Prometheus monitoring. We'll add it in there in our alerts. We'll add it in there. API response time, right? Like this. We'll copy this code and we'll add another line. Add it there. API response time, warning. If it's above 10 milliseconds, warning. If it's above 100 milliseconds, critical. You see that? That's how we define our thresholds. A threshold is simply what we don't want to go over. For example, for CPU, host high CPU load, 80% here. Look at that, 80%. If CPU is above 80%, then it's high. So it means we don't want to go above 6%. So 80% is our threshold. Write these words down. We'll look at it again, but write down. Thresholds, our threshold is 80%. They will ask you in the interview, what's your threshold for CPU? In the industry, every company uses 80% for CPU. However, some applications that are very, very critical, we use 90%.
Give a question, please.
Yes, go ahead.
So in a situation whereby you have a alert that is giving you 80%, what's the next thing to do? Do you just escalate or the
At
DevOps?
80%, it'll be a warning. We always have
Okay.
warning, always have critical. We always have warning and we have critical, guys. Take notes. You always have a warning and you have critical. Does your car tell you that your petrol is almost over, or it just stop on you? Come on, guys, talk to me now. Talk to me.
Gives you warning signs.
It gives you warning signs. So everything in life will always have a warning. Before that girl break up with you, you will know. To give you a warning. What?
My marriage last day.
So you have a warning, guys, right? You always have a warning. Totally, you always have a warning. So before it gets 80, let's say your warning range is 60 to 80. That's warning for you. So when it hits 80, okay, it's warning. When it hits 81, oh, it's critical. Greater than means what? What's the meaning of this sign, greater than? It's greater than 80%. If you hit 80%, is it gonna alarm critical?
Yeah.
No. No. Greater than
80% will be a warning. So from 81 and above.
Thank you. Hey guys, hey, I'm happy I'm teaching you people. You have to pay attention to the details. Greater than 80% is not the same as greater than 80% is not 80. Greater than or equal to 80% is 80. Greater than 80% is 81. Which number is greater? 0 or 1? We're in trouble. Which number is greater, 0 or 1?
1.
1.
Yes, 1. That was a trick question. Okay, which number is greater? 1 or minus 1?
1.
1.
Thank you. Guys, You have to know. You're a monitoring analyst. You have to know numbers. You have to know these things, guys. So we need to monitor these things, right? Pattern of failure responses. Right? Certificate validity for security, usage volume monitoring, network watcher, right? That's what this all we're going to monitor these things. For us to be able to make sure that users have this experience, we're going to monitor these things. Okay. For consumers that internal to the organization, these applications are for employee internal to the organization, critically can be identified based on business usage. For example, the HR portal, internal help desk. What does it mean to the SREs? User experience, same thing, right? Same thing as well. But however, we have internet connections. We have to make sure that the internet is not connected to the applications, only the internet, right? And then the connection, origin or source, geography. When you say that users should work from home, we want to make sure that users are only connecting from home. For the users who want to travel out of America to connect out of the country, they will not be able to connect out of the country because the applications are internal to the company and they only work within the United States. So if you go out of the United States geographically, you won't be able to connect. SREs enforce this. They enforce the connection, origin, and source. Any questions on this? Any questions on this, guys? Okay, no question. I guess it's clear. Federated users, right, are the users such as application third-party vendors, but they're authorized to use client applications. Critically can be identified based on business usage. Example, the VPN applications like Cisco VPN, ADP client timesheets, right? What does that mean to us? Connection and origin source, right? Where the application is connecting from and the source is very important to us. We'll be monitoring user access versus activity, right? User access, people who log in and put their timesheets, people who log into VPN, monitoring the activity. And then also user experience as well, API response, HTTP status code, the failure patterns as well, failure responses. We want to make sure that we don't get any 404 or 504 errors, right? If we see 504, we investigate what? The servers. If we see 404s, we investigate the clients. And then certificate validity as well. And then the connections as well. Then integrations. Under this category, the users by itself are applications. This can be the interface application, which takes input from front-end application and passes the data back to back-end application for processing. Like the IoT app, the scanner apps at Walmart scan the grocery and put it in the application so that you can pay for it. So this can be IoT apps which collect data, like they collect the barcodes from the grocery, collect the inventory, and then send to the application so they can pay. Scanner application at Walmart, WhatsApp. WhatsApp collects the text message and sends to the user, right? So that's the application behind is also is the WhatsApp user. So here we're monitoring for traffic volume monitoring, user traffic, right? How many users are using the scanner application, count per day. So we can know how many users came to shop at Walmart for that day. Token expiration is monitoring. So the tokens that are used to authenticate the application, we monitor that. API response monitoring time, API error pattern. Any errors occurring, we need to monitor those errors. And then the interface and application connectivity, right? Any questions there? Okay. So we have looked at chapter 1, chapter 2, chapter 3, and that's that for now. Any questions on any of these things that I've looked at? Any questions on anything that here that you don't understand? Chapter 1, 2, or 3? Any questions?
Jibo,
Yes.
please, can you go back on greater where you were talking about greater than 80%? I'm still confused about this.
Okay, let's go to a broad. Uh, um, greater than or equal to 80. What does this mean? What does this mean, guys? Come on, class.
Is that anything over 80? No?
Like what? Give me the numbers.
Oh,
Give me
okay.
the numbers that come up. Okay, let's do this. Greater than above 80. Um, 2 equal or less than equal or less than 86. Give me the numbers for this range. Give me the numbers for this range. Greater than or equal to 80 to less than or equal to 86. Give me the numbers in this range.
81, 82, 83,
Let one person go at the same time. Go ahead, Isabel.
81, 82, 83, 84, 85, and 86.
And 80.
Oh, Tolu, that just let me, And 80. Isabel, you miss 80.
Ah, yes, 80, 81, yeah. Sorry.
Greater than or equal to 80
Equal to, yeah.
or less than or equal to 86. Okay, that's that for that. What about this? If I remove the equal to, give me the numbers now.
Shall I continue? Okay.
No, let somebody else speak. Use the answer. Who else wants to give the answer?
So it's 81, 82, 83, 84, 85.
Kwasi, is it understood now?
Hmm. Yeah, I understand that when you say greater or equal, yeah, I see. But why you just say you say this when it start to be 81 that is critical.
Because in the application, we said greater than 80%. So from 81, it's going to start being critical.
Which means 80 is a warning sign because
Okay.
80 is
80
not
is
greater.
warning. Thank you.
Okay. So anything below 81 is warning. Okay.
Yes.
Right.
But for simplicity and for English language and grammar, we don't go say less than 81%. We'll say greater than 80%. In fact, greater than 80% is equal to less than 80%. 81%, sorry. I don't want to confuse you too much, but it's just this is what's it called? Algebra? Is it algebra in college math, right? Something like that. Is it? Or sets, or prime numbers, something like that, right? It's basic arithmetic in that we did in college, right? You see here we have warning, you have critical. Every metric, and a metric is this thing. CPU is a metric, memory is a metric, all these things. Every metric has a warning and a critical, right? Okay, disk space. This is the warning for disk space. This is the out of disk space. So you see, if it's less than 50% left, right, it will show warning, post out of disk, warning, post out of disk. It's going to show a warning. What's the criticality for that? Where is it? Warning. And do they have it here? They don't have it here. Where is it? Okay, memory. How's other memories? Warning. Website down. Another one. Post high CPU warning. Then high memory usage. Critical. Oh yeah, right here. File system is full. So the critical metric for a host out of disk space warning is file system is full. So it will go from warning, oh, we have 50%, less than 50% disk left. Warning, 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 warning. If you don't do anything, it say warning, this is almost full. Then it will show you the value, 38% left. What goes into query to pull out from that server is Prometheus. You see this value here? It passes that number here. Prometheus will run a df-h. Prometheus goes and run this command on your behalf. And look at that disk and say it's left 3%. And collect that metric and pass it here. And that's how you're able to see it in your alerts via email. Okay? All this is simply JavaScript code. This is all JavaScript code that you don't have to write. It will always come. Datadog has it. All this monitoring, they have it automatically for you. You don't have to write it. You will just go and copy from the documentation and paste it. As I say, your job is very easy. You don't have to write this stuff. You just go and copy it and paste it. And you can always use this example that you see here, or you always have a document like this to enable it. For example, let's say you want to implement Datadog monitoring. You come here, you type medium, enable Datadog monitoring on EC2 instance. Boom. That's it right there. How to monitor EC2 instance of Datadog. Boom, that's it. Everything is there. All the steps for you. The commands, everything is there for you. You don't have to do anything. You don't even have to think how to do it. It's already there. That's the command. That's the sudo systemctl. All you have to know, VI, all you have to know is Linux. System. That's all you have to know. If you know Linux, you will never, ever struggle. That's it. System, everything is there for you guys. And that's it. You have enabled Datadog on EC2. That's it. Look at that. 4 minutes read. So I'll give you guys more monitoring project this weekend, but you have to know Linux. You have to know Linux. You have to know how to VI. If the file doesn't exist, create the file. Create the file. Look at this. They're not there to create a file here. They just say VI. This means this is creating a file called datadog.yaml. Create the file, guys. And the picture is right there too. So you should look like this in the picture. And then you restart Datadog agents. This is a command that you need to know how to do all the time. You need to know how to restart the agent on most things. Datadog agent, Prometheus agents, database agents, application server agents, because that's your job as a monitoring guy. You need to log onto the server and restart the agent so the service comes up and users can log in and do their business. Okay? So I hope we are clear as greater than, less than, other things. Okay? I hope we're clear with that. So I expect you guys to do this project this weekend, plus the project I'm going to give you guys. Okay? Any questions? Any questions, guys? Okay. So chapter 4, how different teams are structured for an application. So let's look at an application. This is safe for Linux Enterprise. I'm not going to go too deep into this because it's not very our task, right? If you look at that, this organization, you have the enterprise, you have strategic teams, you have epic owners, business owners, system architect, product management, agile teams. This is the developers and the testers right here on the side right here, right? They write code to build the application. When they're done building it, developing it, testing it, to release it, we are on this side right here, right? We are in this part of this team. Maybe the DevOps team or the cloud support team or the ops team, okay? So we are on this side of the spectrum. We're not in the beginning, we're at the end. That's all. We're not in the beginning, we're at the end, okay? So that's how we do our work. The DevOps model, DevOps stands for development and operations. The DevOps engineers, what do? They plan, they code, they build, they test, they continuously integrate, they release, they deploy, they operate, they monitor, continuous feedback. So we are SREs. We are going to release, we are going to deploy, we're going to operate, we're going to monitor, we're going to provide feedback. That's it for us. However, some SREs are required to do continuous integration. Some, like the senior ones. But most of you will be doing what? Monitoring and operation. Most sometimes you do deployments or releases. If you really want to make a lot of money, you should be doing release, deploy, operate, and monitor. These 4 things here. The CI/CD, no. Only release, deploy, operate, monitor. Release means that the application goes live. When you develop an application, they build, they test it. They don't just go live immediately. Because going live means that you're going to affect customer operations, right? That's what going live means. So you have to schedule a time when you're going to go live, and then boom, you go live. Then just get up and go live, right? Any questions there? So that's what SRE is. So we'll learn release cycle, release schedule, deployments, operate, and then monitoring, okay? So the SRE team is made up of this. This is the SRE team: application support, environment support, change management, incident management. This is our team. Most of you will be working in application support, you'll be working in environmental support, but you also be doing some change management and incident management. So, section 4 summary, you have a Scrum team. This is the Scrum Masters. You have the business owners, product managers, system architects. This is me, the architect, right? You have the product owners. You have the Scrum. I don't know what this is. It's a Scrum thing for Agile. You have a Scrum Master here. They have the DevOps engineers. DevOps engineers, they have their own team. This is their own team. Then you have the SRE team, which is application support, environmental support, change management, incident management. Some of you just been on incidents. That means you just work on tickets. You're not proactive, you're reactive. You react to things that happen. Oh, server is down, you react. Or some of you will be working on change management projects. Oh, we need to upgrade the application from version 1 to version 2. You go and do the upgrade. or you're doing environmental support, monitoring EC2 instances, creating monitoring solutions, or the application support, making sure that latency is low, those things, right? This is what your job is. So you fall in one of these categories, or all of the categories, or two of them, or three of them, depends on the company that hires you. So on the interview, what do you say your day-to-day task? When I ask you what have you done? You say I've performed application support, I've performed environmental support, I've performed change management, I've performed incident management. This is what you say. That is your job, your day-to-day job. Most recruiters will ask you in the beginning, what is your day-to-day task like? What is your day like? You say, oh, I do application support, API response codes, I handle HTTP status codes, I monitors, all those things. You have to speak what you know, what you have done. So the role of an SRE in a production environment is not automation, but monitoring the health of the application, capacity planning, change management, system reliability, right? Communication, issue debugging, creating statement of procedures, and defining SLAs, right? All of this can be automated via via this solution here. This automation solution. So that we'll just sit back and we'll just get alerts. You can either look at the dashboards with your eyes every single day, right? Which is very painful. That means you can go and look at your dashboard like this. Every single day, you're just watching this. It's called chat watching. Or you can just go and configure this automation solution and then sit back and wait for an email to come through. Which one do you prefer?
Sit back.
Exactly. I know only Kobe can say that. Sit back and wait for the...
That wasn't me.
Who said that?
Chris.
Chris, yeah. Chris wants to sit back and do watermelon meat. Yeah. We all want to sit back, guys. So let's automate the solution, automate all these things, using this solution like this, automate all these things, and sit back and just wait for an email with a critical alert to come in. If a warning alert comes in, what do we do? Do we do anything? Somebody like AY, if a warning comes in, he was just like, Massa, I'm busy. Only when it's critical that you will say, okay, let me step in here.
I'm calling you as well.
Guys, when you get a critical alert, please don't call me. I'm not available. I'm unavailable. They know they see me. Right? So system reliability is important. Online system providing services to customers needs to be monitored. Right? If customers are using on our online systems like a Wells Fargo mobile banking app, those apps, online apps, it needs to be monitored very, very heavily. Ensuring product developed for customer is working as expected. But we're not sitting there looking at it with our eyes every day. Prometheus agent is running on the system every 5 seconds, every 3 seconds, querying disk, querying memory, querying CPU, and sending us an alert only if it goes above 80%. It collects memory, collects CPU, collects disk space, but it doesn't send us an email. Why, Kwasi? Why will we not get an email?
It's not critical.
Okay.
Because it hasn't gone over 80%. Oh, guy. You will only get an email if it goes above 80%. How? You will not get an email if it's at 79%. We get an email for this. What for this?
No.
No, you're not gonna get a host high CPU load. No, 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 no. Guys, you will only get an 80% if the threshold hits. You want the threshold not to hit. You want the threshold not to hit. Trust me, guys. You want to have a quiet life, a smooth and quiet life. So everything is normal. But when this hits 80%, 81%, boom, email. This hits 100%, boom, email. This is 100%, boom, email. Ooh, that's when the house is on fire. That's when you start panicking. So you can have 99 days of quietness. And then the one day that critical alerts go off. But let me give you a little secret, guys. When everything goes off at once, guess what? It could be what? You guessed it. False alarm. This happens a lot. You know why? You know why it happens? A developer is working on that application server, and he did not tell you that he's doing something on that server. And because we're monitoring memory and sleeping on that server, he goes and shut the server down without knowing that he was supposed to tell us to temporarily turn off monitoring. Temporarily turn off monitoring. He goes and shut it down. And then from nowhere, we start getting emails. Boom, 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 boom. We want to investigate. We go to that server, it's shut down. We start it up, it comes up, everything goes back to normal. He sends you an email that, why did you bring up the server? I was testing something. You say, hey, my friend, did you inform me? Okay, we're on the same team. I support you. I'm your SRE, I'm your monitoring guy. Before you turn off your server or do some work on the server, email us that, hey guys, I'll be doing some testing on the application server between the hours of 1 p.m. to 4 p.m. You, the SI, will tell that guy, no, that's not a correct time to do work because business is still going on. Can you schedule your work for Saturday between 8 a.m. and 10 a.m.? The reason you tell that is so that because you'll be able to support him. If something goes wrong with that server on Saturday morning, you will wake up on Saturday at 8 a.m. to support him. Or if you don't want to wake up at 8 a.m. on Saturday morning, you tell her, hey, can you schedule your testing on that server for Saturday at between 1 p.m. to 3 p.m.? If he accepts, boom. At 1 p.m. to 3 p.m., you join the Zoom call. You turn off monitoring, right? He goes and does his work. He tests it, bring the server back up, and then you turn on monitoring again, and then you go about your day. Guys, trust me. 95, no 95, no, that's too much. 75% of the tickets that I worked on were false alerts, with false alarms. It happens so much. So the first thing you do, you should check when you have an alarm, check if the server is up and running. You will save yourself so much stress. Developers shut down the servers a lot. When they are doing something that is tying them, that is making their life stressful, they're just going to start shut down the server and bring it back up. So it creates all these alerts, unnecessary warnings. Server is down, service is down, host is unavailable, all these kind of things. Be getting emails, text. It just causes too much. It's called white noise. It's called white noise. It's like smoke, white smoke. It doesn't have any fire. So, I mean, communication is very important. And before you two want to turn off monitoring on the server, inform the company that, hey guys, we'll be performing maintenance on our systems on Saturday between 1 p.m. to 2 p.m. Central Time. So we'll be turning off monitoring. Please avoid doing any work during this time as the servers will be unavailable. That's communication. See, communication is even more important than all these commands here. You must inform the company that you're going to be turning off monitoring and doing some maintenance on the work on the weekend. You have to. Any questions? So, reliability of systems. Detected issues should be reported immediately. There you go. I just said it. When you detect any issues on the system, service is down, check if the server is running first. Don't go and tell the company that server is down because AY shut down the server because he wants to test his stuff. Check first if it's up and running. If it's up and running and the issue is still there, okay, you should go and email guys. Hello guys, I'm looking into system that occurred at 10:45 a.m. this morning. CPU is very, very high. We'll be investigating the server, or investigating the issue on this server. Just send an email out, that's all. Don't know that you're working on it. Okay? How do you know if something is not working? You get an email alert or you watch the dashboard. Which one do you prefer? Monitoring the dashboard or email alerts?
Both.
Mr. Chat Watcher. You like to watch chats.
Email alert.
Email alert, guys. Come on now. Who wants to be watching at all these graphs, all these things? Or you want to be watching these things? It's very stressful life. That's our Champions League is at 2 p.m. We're drinking one cold Heineken at 2 p.m. and we're watching the football match. We're not going to be watching this chat. If an email comes, we'll hear that sound ping. Then we'll go and check the email. You understand now? Yes. That's why you see when you start working at IT, you gain weight because you're relaxing, eating chips. There's no stress. The verticals of monitoring, you have to monitor security, user access connections, all those connections, client server connections, right? For monitoring the network, security, application health, latency, throughput, database, response time, request and response, system health, latency, application functionality. Oh, I cannot buy a flight on pricing.com. Oh, something is wrong. Let's check. We'll see. Request count, load balancer failures, all those things you will check. Okay. So those are the KPIs. KPIs stands for key performance indicators. Security monitoring. Well, our time. We'll continue tomorrow. But we're getting at a place where this is the meat and potatoes of this class. When we start tomorrow, or sorry, Wednesday, we'll start now installing these tools. From now on, it's only going to be tools. SolarWind, Intruder, AWS Guard Duty, CloudWatch, Splunk, Nagios, these tools. We're going to go into these tools, right? So we'll stop here. This is a good place for us to stop, right? On Wednesday, we may not have class. I'm not sure, guys. Let me pause the recording first before going to this. Let's talk matters arising.